Before we start the video, let me give you a brief introduction about myself. I'm Chandresh Mahajan, who is founder and chief educator at Exergic, which is India's most trusted and comprehensive institute for online gate preparation. I got an All India rank 37 from Gate Mechanical Engineering, and I am an ex Indian Oil officer, having 6+ years of teaching experience as of now. To know more about our GATE courses, you can contact us on these details. Also, you can download Exergic Gate Preparation app from Google Play Store. The link is available in the description of video.
Now let's discuss the next mode of heat transfer, which is convection. Suppose you have a hot reservoir. You have a hot reservoir, okay, which is at a temperature of 35 degree Celsius, okay, comparatively hotter than the ambient air. That is why we are calling it hot. The ambient air is at 25 degree Celsius, okay. So what will happen? Since there is a temperature difference, so heat will flow from higher temperature of 35 degree Celsius to a lower temperature of 25 degree Celsius. What will happen? Due to heat flow, currently this air is at rest. The air is not moving, the air is at rest. When I say the air is at rest, it means that there is no bulk movement of air. The atoms and molecules in the air are obviously not going to be at rest. There are going to be vibrations, translations that you cannot see from the naked eye, but that is going on. That is why it has some temperature, right? But when I say that air is at rest, I mean that there is no bulk motion. There is no bulk motion of the air. Wind is not blowing, air is not flowing. Air is at rest. At intermolecular level, there will be intermolecular activities, molecular activities like vibration, translation and all those things. But as a whole, air is not translating, as a whole, air is not flowing. Alright. What happens when air is at rest and there is a temperature difference? Conduction will take place. Always remember that whatever cases we covered in conduction, for liquid, for gas, for solids, there will never be any bulk motion. I did not mention this word at that point to unnecessarily confuse you. But here we will be discussing about bulk motion. That is why I am telling you that in conduction there was no bulk motion at all. When we were discussing conduction in air or in any liquid from one point to the other, we were assuming that the fluid is not flowing, the liquid is not flowing, air is not flowing. Whatever was the motion from high temperature to low temperature was happening at the molecular level. The molecules were moving, but as such, on a macroscopic level, the fluid, the liquid, the air, the gas was at rest. Okay. Now, in this case also, same thing is happening. Air is surrounding this hot reservoir, but there is no bulk motion of the air. Air is not moving as such. But due to molecular movement from the hot surface, what will happen? Temperature will start propagating. Right? Heat will start flowing from high temperature to lower temperature, and this temperature will keep on increasing. Correct? The temperature near this surface. Okay, let's forget about these places. Let's consider just one surface of this hot reservoir. So the air in contact with this hot reservoir, in these regions, the temperature of that air will keep on increasing from 25 degrees Celsius to 26, 27 and so on. A point will come when it will reach to, let's say, 32 degrees Celsius. Okay, and even higher than that. What is the maximum temperature up to it can reach? Obviously, almost close to 35 degrees Celsius, not above that. Okay, but as this temperature difference is decreasing, the rate with which heat was flowing will also keep on decreasing. What I mean to say is, earlier it was at 35, air was at 25. There was a 10 degrees Celsius temperature difference, right? But as 25 keep on increasing, reservoir's temperature does not change, right? That's why I'm calling it as a reservoir. So its temperature is not changing. It's not a finite mass body, right? We have discussed that in thermodynamics. So as 25 degrees Celsius keep on increasing, their temperature difference keep on decreasing. And when temperature difference decreases, rate of heat flow also decreases. This is the concept that we will study. Okay, this is a concept of conduction of Fourier's law. We will study that. You don't need to worry about that, how and why this concept came. We will thoroughly discuss that. But at this point of time, just consider, just take it on my word value that this is correct. You can have an idea of this from the current analogy, that when the potential difference decreases, the difference of voltage decreases, current flow decreases, right? V is proportional to I. What is current flow? It is the flow of charge. In a similar way, what is heat? Conduction. It is the at molecular level, it is the flow of those molecules, the flow of heat per unit time. Correct? So from that you can understand at this point of time. I am not explaining this law at this point of time. We will completely, totally discuss this law in conduction. It is Fourier's law of conduction. So as the temperature difference between these two is decreasing, earlier it was 10, now it is only 3, the rate with which heat is flowing from higher temperature to lower temperature, that will also decrease. And as 32 will keep on increasing, as it will almost reach 35, what will happen? The rate of heat flow will almost be negligible, right? And since the rate of heat flow decreases, the speed with which the room is getting heated up will keep on decreasing. When temperature was 25, it was very fastly, heat was flowing very fastly, the temperature was rising very fastly. From 25 to 27 it will reach very quickly, but to reach 34 from 32, same 2 degrees Celsius difference is there. 25 to 27, 32 to 34, but 25 to 27 will happen faster, but 32 to 34 will take more time because delta T is less. So rate of heat flow, the speed with which heat is flowing, will be less. So time in which the temperature will rise will also be less. But suppose you want to do it faster, okay? You are doing this heat transfer, let's say in any particular machine, in any particular industry, and you have a specific purpose why you are doing it. So you want to do it fast. You don't want to do it at a slower pace. So what will you do? This is a problem in front of you. I have briefed you about the problem. What will you do? Look, if you can replace this 32 degrees Celsius air with less temperature air, then the heat transfer will be faster, right? You have air all around, right? You have air particles all around. If by some method you manage to replace this hot air with somewhat colder air from the ambient region, from the other ambient region, then what will happen? Fresh air at 25 degrees Celsius will come in contact again. So what will happen? Delta T will again increase. Rate of heat flow will again increase. Right? That is what we do in convection. The earlier method that I was discussing till this point, that heat is flowing, temperature is increasing, what was that? That was conduction, when there was no bulk movement of the fluid. Fluid as such, or the air as such, was not moving. It was at its place only. Only molecular diffusion and collision were happening. But if you do bulk motion, if the fluid, the air starts to move, starts to flow, then what will happen? This 32 degrees Celsius air will be replaced, this air will be replaced by other patch of air which is at 25 degrees Celsius only, right? Because the effect of 35 degrees Celsius will only be felt up to a certain distance. After that, air will be at 25 degrees Celsius only, right? 35 degrees Celsius cannot increase the temperature of whole planet, right? Only up to a certain distance the temperature effect will be present. After that, it won't be present. The air will be at initial temperature only. So by using some fan, by using some blower, you managed to replace this air with this air. Then again 25 degrees Celsius air will come here. Fastly the heat will flow. The heat transfer rate will again increase. Correct? So in case of convection, we have conduction. Initially we were having conduction itself. As a result of that, the temperature increased from 25 to 32. But you have to add bulk motion to conduction. Then the type of heat transfer that you get, then the mode of heat transfer that you get is called as convection. So whenever you are making the fluid flow, whenever you are having a bulk motion in the fluid, and conduction is anyway there, right? So that type of heat transfer is convection. We all have seen and experienced and used convection heat transfer. How? Suppose you are sipping a cup of tea, or you are sipping a cup of coffee, okay, and it is hot. It is, let's say, at a temperature of 60 degrees Celsius. So what will happen? As a result of that, the air near the surface of this will get hotter, right? Its temperature will increase. But since its temperature keep on increasing, the rate with which this tea was losing heat, that rate will decrease. So initially the tea will cool fastly for certain degree, maybe from 60 to 59 to 58 it will come very fast, to 55 it will come very fast. But after that, since the delta T decreases, the temperature difference between this point, means up for the air above this surface, and for the T, that temperature difference will decrease with time as this air keeps on getting hotter and hotter, right? And this keeps on getting cooler and cooler. So since delta T decrease, rate of heat transfer decrease. What you want to do? You don't have the time. You have to go to the class. You have to go to the office. You want the coffee, the tea to cool quickly. And that can happen when rate of heat transfer will be fast. It will fastly lose the heat. And when it will fastly lose the heat? When delta T will be more, as I told you. And how you can make delta T high? By replacing this air with another air, another ambient air at lesser temperature. So what you do? You blow the air, right? You blow the air. So what you do? You blow the air, right? And that pushes this hot air far away from the surface of tea, and this patch is blown away and it is replaced by a cooler patch of air at 25 degrees Celsius. What will happen? This 25 degrees Celsius air will come in. Again the heat transfer rate will increase. So if you look from the perspective of this tea, again it will start losing heat faster. So what will happen? It will cool faster. You will be able to reach your office or your college early, right? So this is the funda of convection, right? Conduction coupled with bulk motion of the fluid. Now there are two types of bulk motion. One type of bulk motion is the one in which you apply some external agent to make sure that the fluid is moving. Just like this case, right? We use the external agent, right? Our mouth or the blow that we made was an external agent. You may use a fan for that, you may use a blower for that. So when we use some external agent like fan, like blower, for making the bulk motion to make the fluid flow, that is called as forced convection. That comes under the category of forced convection. First type of convection. The second type of convection is called as free convection. In case of free convection, you do not use any external agent for bulk motion. The bulk motion happens automatically. Now you may think how bulk motion is going to happen automatically. Let me give you an idea. Suppose you have kept an egg, a hot egg, on the surface like this. Okay, what will happen? The air which is in contact with this hot egg, the temperature of that air will increase, right? This air will keep on getting hotter and hotter. And what happens? When gases heat up, when gases get hotter, what happens? Their density decreases, right? Because air can expand, it can contract. Upon receiving heat, it expands. So what happens? Its density decreases. Now imagine a situation where other areas in the air are at the normal room temperature, but the air which is near the egg, the temperature of that has increased and that has become lighter because the density has decreased. So it is hot air, basically it is hot air near the region of egg which has become lighter. And from the fluid mechanics perspective, you see this problem. You have a lighter patch of fluid in a dense fluid. Consider this 25 degrees Celsius fluid as a dense fluid, and in that dense fluid you have a lighter patch of fluid which is lighter than the bulk fluid. So what will happen? It will start to rise up. Just like you have some lighter density solid immersed in a liquid, in a similar way, lighter density, this patch of fluid immersed in a heavier, in a higher density fluid, what will happen? It will start moving up. Just like hot air balloon, right? We have seen these hot air balloons in movies and in Discovery Channel. I don't know, you might have seen it in person. I haven't seen it yet in person. So we have seen this hot air balloon. So this is also, having the same funda, that the hot air within the balloon has lesser density. So this makes the air move up, because the atmospheric air is having higher density. Lighter density fluid moves up in the higher density fluid. So the hot air balloon rises. So in a similar way, this hot air patch will rise up, and surrounding air, which is at a lesser temperature will rush here. This air will rush in that region which has been emptied, which has been vacated by the hot air. So what will happen? Hot air will keep on rising, and the colder air will keep on replacing it, and this will be a cycle. This cold air also, its temperature will increase, it will move up, it will be replaced by another patch, another bulk of cold air. So in such way, flow will be set up, a current will be set up, which is called as convection current. Convection current. Current does not think current as electric current. The flow of such fluid is also called as current. You would have heard the words like underwater current and things like that. So it is used for defined motion of any fluid, liquid or gas. So convection current will set up in this manner, right, here and here. So you see bulk motion is happening here. Are you using any external agent? Are you applying some blow, or you are using some fan or blower? No. Automatically it is happening. So such type of convection where you have conduction, that is why the temperature of this air is rising, by conduction, but that is coupled with bulk motion of the air. But this bulk motion is self-induced, right? It is happening on its own. So these type of convection fall in the category of free convection. All right. Also have a look at this diagram which shows the convection current from the palm, from your palm, right? You can see that the air which is surrounding the palm is moving in a definite direction. Your body temperature is obviously higher than the temperature of the surrounding air. So you can see that how convection currents are being set up. Just like the example of the hot egg that I gave you, you can see that the air in contact with the palm is getting hotter and it is rising up in the air, right? And you don't even need to look at this diagram. If you have ever observed your shadow in any winter afternoon, okay, when you observe closely your shadow, especially the region of your head, you will see some movement, some air movement. In the shadow, you will see the movement. I don't know whether you have noticed this or not, but you will see some movement, just like the movement I showed you in the diagram. That type of movement you will see in your shadow if you look it up close from your head. So basically, whatever is your body heat, that goes up. 70%, 60 to 70% of your body heat in winters is lost through your head. Because if you look at your body from the top, head is the most prominent region of that particular projection. So that heat is lost through free convection, from the top part of your body, from your head. That is why you might have observed that in those places where you have very chilling winter, you see that they carry something on their shoulders. If you have seen some movies or some series where they are showing people in the region when it is snowing very heavily and it's very cold, you will see that they wear the skin of the animals on their shoulders. They also have long hairs, right? These all things make sure that heat gets trapped in your body. Your body does not lose heat from free convection. From your shoulders to the above region, from your head to the above region. So you make sure that you make a blanket in these regions to make sure that heat of your body stays in your body, you stay warm, right? That's why I was telling you that this subject, we have not even started this subject yet, right? There is no concept as such that I have told you. Whatever I have told you till now are just the surface of the subject. But you see how great practical implications it has on so many different regions, on so many different areas of your life. Okay, so this is something which is very interesting about the convection. Also, I want to ask you a question here, and it is a very popular question. It is asked in exam as well, that suppose you have a plate which is a hot plate. It's hot as compared to its ambient surrounding. Okay, so what will happen? The top surface, this is the top surface, and this is the bottom surface. Now tell me on which surface convection currents will set up. On which surface basically it will be lost from convection. Tell me. There is no bulk movement. Okay, don't consider any bulk movement. Look, the top surface, what will happen? The air in this region will start to move up after getting hot. Just like the example of the hot egg that I gave you, right? This will become hot, this will start to move, the cold air will rush into this region and a convection current will set up. So this will be having free convection, right? What about the bottom region? The region near the bottom surface will again, obviously it will also get hot, right? But as it gets hotter, it gets lighter, it wants to move up. But how can it move up? You have a plate above it, right? So it will be trapped there. It wants to move up. Maybe some of the air from the side regions can escape from the side, but mainly the region below the plate, it will not be able to set up any convection current. It will be trapped there, right? So in the bottom region, the heat transfer will be occurring from conduction. Since no bulk movement is happening, and bulk movement is not possible because this wants to move up, but there is a plate, so it will have the heat transfer from conduction only. If you want to have convection in the bottom part, you have to do forced convection. You can set up some fan here, right, which will blow the air and which will push it apart. So that is a separate thing. We are not considering forced convection here. Interesting, right? Similarly, consider this case with a cold plate. You have a cold plate here. Okay, what will happen? The air which is below the cold plate, that will get cooler, and as it gets cooler, it gets denser, it will get heavier. It will compress in a way, not compress, it will shrink in a way, right? So it will get heavier, and as it gets heavier with respect to the ambient air, it will start to fall below, right? So convection current will set up, but in the opposite manner of the first case. So in this case, this will keep on falling down and the air which is in the nearby region will replace it. So convection current again will set up, but in this case it will set up in the bottom layer. What will happen in the top layer? The top layer in the vicinity of the top surface will get cooler, will get heavier, but it will settle down on the top of the surface of this plate itself. It is heavier, but it cannot move, it cannot flow down because you are having a plate here, so it will just settle down on the plate. So on the top surface, conduction will occur, right? You have also experienced this. Whenever you bring ice tray from any refrigerator, recall any example, wherever you have seen ice tray coming out of refrigerator, you will see that the portion of air that you are able to see near the ice tray, it has a movement on the downward direction, right? The air near the ice tray, it is quite visible, it is quite whiter, not transparent, quite white it looks. So you can see that it moves down, right, around the ice tray like that. So same thing is happening there. The top portion is trying to move down, it cannot move down, it stays up. From the side it may fall down a little bit of that, but mainly bulk motion will be happening from the downside. So this happens for the cold plate in a somewhat hotter surrounding. So these are the very practical examples of convection, especially free convection. These questions can be asked to you, that which surface is going to have conduction, which surface is going to have convection. You have to understand and apply this concept wherever such questions are asked. Again, I am telling you, a lot of concepts are to be covered in convection. This is just an introductory unit where we are just understanding what these different modes of heat transfer are, how they function, and just an overview of them. The detailed study of convection, both forced and free, we will separately do in the unit of convection.